Perfect. Thanks.
And it's starting in 5 seconds.
Good.
Okay.
Okay, here we are. Okay, good afternoon, everybody, to the second session of our AquaWatch meeting, Future Needs of Our International Partners. My name is Carsten Brockmann. I'm the Managing Director of Brockmann Consult and working with the AquaWatch team since a couple of years. I think we have an interesting session, and I will guide you through the program for this next hours. Very unpolitely, I will make the start, and I have to find the button where to share screen. Oh, speaker chat. Okay, present to audience. All right, can you just confirm that? Okay, I can see it myself that I share the screen. So this is session 2 on the future needs of our international partners. Okay, thanks, Mary Beth. So when we talk about future needs, we have to see where do we start from, and we saw in the last session partly where we start from, what people are expecting, what they are doing. When we look at what's on the delivery side available, we have big programs run by the big agencies now for a couple of years, giving us routinely ocean color derived satellite products. I have shown you here from the NOAA CoastWatch side that we have from VIRS single instrument and merged instrument products of remote sensing reflectances, but also chlorophyll concentration in daily observations, in daily means, in monthly means, weekly means. And the same from Sentinel-3, so from individual instruments. And then we have products like the Anomaly, where the daily observations are compared with long-term averages. So that's what's from the US side. Another example is from the European side. We have the Copernicus program, Europe's Eyes on Earth, where we have for coastal areas and the blue ocean, but we are focusing here more on the coastal areas, from the so-called Ocean Color Thematic Assembly Center, Ocean Color TAC. We have a similar suite of products as we have seen it from NOAA CoastWatch, global ocean optics products, so remote sensing reflectances. We have European seas, we go more than in the regional area, chlorophyll concentration, and this from single instrument or merged from different instruments. And when we look really into the near coastal areas, we go into 100-meter size of products with the ocean color products derived from Sentinel-2, which is more turbidity derived information. So that's the kind of information level 3, daily, monthly products, and level 4's gap filled, what's available here. And very similar on the inland water side in Europe, we have from the Copernicus Global Land Service, lake water quality, a very comparable suite of products, again on the 300-meter scale based on the ALGE data mainly, and then also going to 100-meter for the higher spatial resolution. But there are also, beyond this basic type of information, which, as I said, is now quite established, I would say, with varying quality, of course. We talked about this. There is emerging, let's say, more specific type of information, like this example, again, from Copernicus. This is foaming algae, Phaeocystis foam, very near to a port in Belgium, in the Netherlands, which caused some problems for tourism here. That's also one example. And another way where it is emerging is when we look into climate change, and there is the climate change service, which is also looking closer into coastal areas. Or when we look into NOAA Coast Watch, on their side, we have the case studies very similar to what we have seen before on harmful algae blooms, Turtle Watch, looking into coast and ecological processes in the coastal zones. We have heard from Marc, I think it was, on biodiversity type of questions. We have on the US side the Hurricane Bureau, so that's more specific type of information on these basic information. And there is, I think, on all the sides, not only in Europe and the US, but I think also globally, there is an R&D agenda which is bringing us into this future of a couple of years ahead of us. And since this is most easy for me to understand or have access to the information is on the European side, the evolution strategy for Copernicus. And if we just look at some of the priorities here, they are looking at the next generation of integrated ocean forecasting system, efficient methods to account for complex observations and modeling error structures, observational data sets and validation procedures suited to next generation of ocean prediction system, including consideration of observation quality assessment. There is on the coastal environment, I'm just reading the bold parts now here, improved algorithms and improved resolution. That's for the future. And then looking into plant functional types, PFTs, and other products going beyond single instrument and then merging the medium and high resolution products, better consideration of the land, sea, and other interfaces, development of understanding inputs from freshwater flows and associated river inputs, and habitat mapping, biochemistry, marine biology, more consistent processing and assembly of data from heterogeneous observation platforms, or benefiting from the evolving information technology, so reprocessing of existing data sets, use of machine learning, now working on more than 20 years old color observations, applying data mining techniques and automatic extraction of analysis patterns from the data that we have from the big data sets, and then using cloud processing capabilities for user-specific high-level processing. So that's a little bit on the R&D agenda. And in this session now, we want to see what are the needs from our partners. So this can be information needs for climate change, impact monitoring, climate change mitigation strategy, effectiveness monitoring. So our mitigation strategies working. I think what we have seen, coastal zones, water quality, ecosystem health, biodiversity, offshore technology, these are all subjects. Inland water resource management, SDG monitoring, crisis management. I think this is what we will hear from our international partners, including NGOs. Conservation International will talk today. The EFIs like World Bank, Harsh is the next in the loop to talk after me. United Nations program, UNEP, and the NGOs also, Prime Water, IWA, International Water Associations. So we will see how does this fit with the R&D agenda, which I have just presented, and then we can talk about which information products are needed from our space agencies and from international programs delivering water quality information for the benefit of society. All right, so this was the introduction, and we have now 3 presentations. The first one will be given live by Harsh from the World Bank, and then we have 2 pre-recorded from Samuela from the International Water Associations and Derek from Conservation International, followed by our Q&A session. So with this, I will stop my introduction and hand over to Harsh, please.
Thanks, Carsten, for that introduction. My name is Harsh, and I've been working at the World Bank a long time, around 26 years or so, on environment, water resources, and climate and technology aspects. I'm currently the global lead for disruptive technology at the World Bank. In our environment, natural resources, and blue economy global practice. And I also co-lead our hydroinformatics group in the water practice as well. Hopefully you can see my screen. So what I'll do today is really quickly go through what water quality might mean in a larger development context, and to the heart of what we were asking today, which is what are the future needs that are evolving in this regard, right? So we've all know that water quality is affecting a lot of different aspects of development, whether it comes to drinking water, whether it comes to larger biogeophysical processes such as sediment transport and other complex phenomena there. We also know that increasingly there's concern about not only pollution from chemical parameters, but also resulting issues from the point of view of biological issues, such as this is the water hyacinth in Lake Victoria, which chokes up a lot of the navigation and ports, and is a major problem in that area. Everybody, including the bank, has been trying for many years to try and see how to address those issues, as well as a lot of issues to do with toxics such as chrome, southern India, or looking at, especially now more and more, the open oceans and larger lakes like Lake Karun in Lebanon, or these polluted beaches. A lot of these were in countries which depend on tourism. And increasingly, plastics have become a major source of concern along with other waste, resulting in problems both for human and animal health. So we have all seen the stats. Lots of people lack even basic safe drinking water, where safe is primarily determined by water quality. A lot of issues relating to safe sanitation, which is a big driver in many places of poor water quality. There's a lot of human health concerns with about, I think this is our latest set of numbers from Dhaka this week, which is 827,000 people unfortunately dying in low and middle income countries due to poor water quality. There's a lot of sewage going in, much of it untreated around the world. And a lot of these newer elements, such as plastics, have now become a big issue around especially these coastal and marine and open ocean areas, where it's also affecting both humans and others, although the human bit still needs a lot more work. Now, at the World Bank, for those who may not know the details, we are an international development organization. We have many different parts. IDA, IBRD is mostly for support to different levels of countries, to the government. IFC is to the private sector. MIGA is for multilateral investment guarantees, and ICSID is for settlement of international disputes. So all of us together are the World Bank group, and there's a lot of, for example, work that's going on under 4 different headings, something on equitable growth, finance and institutions, human development, education and health, and so on, infrastructure such as energy, transport, and digital development, and sustainable development, where I belong, which includes a lot of water, environment, and other aspects. And a lot of the work is done through knowledge convening and financing. We are the largest multilateral source of financing on water in the developing world, and also have large programs to help clean up water as well as manage water resources in a more sustainable way. And increasingly, with the more use of nature-based solutions and new technologies. And a lot of these new technologies could be related to work on especially data, collecting data in new ways, by analyzing data in new ways. We heard about cloud and other aspects just now, and also to use it for better decision making and making it more accessible. A lot of new ways to make things, including 3D printing, which could also be used for data collection through housing, like the 3D paws and so on, and new ways to connect people, as we are doing right now. So a lot of these may translate into the work, for example, that we are supporting many countries on improving the water quality monitoring, for example, along the Ganges River here, with many different programs, using, for the first time in India, a lot of these automated sensors. And a lot of these then provide even intra-day variations, which are very high, which help develop slowly a better knowledge base to work on. In addition, there's a lot of work that's starting up on community monitoring, where communities are being used to monitor not only the permeability of rivers, but also the water quality, and taking samples for the future so that they can become part of the system of monitoring and also benefit from its analysis. But the big change is coming, as we heard, from Earth observation. And there's a lot of really new types of systems that are out there, but it's very limited right now on the water quality side. And so that's where, as we look in the future, the big change is in terms of the way these get integrated, in terms of these bottom-up systems with gauges, with the top-down systems from satellites and drones and aerial surveys and so on, as well as data that's rescued from termites, as well as different types of analytical systems, which then, through the power of cloud services, can help make dashboards to improve the way decisions are made in this regard. So at the bank, we've also made a range of these interactive dashboards to showcase what other people have done in terms of putting data in the public domain. And a lot of these can be seen also in different languages to help people explore these. You'll see links to these later if you want to explore these more. But the big challenge we have is that on the environment side, there's very little related to water quality that is available right now. A lot of it tends to be related to things such as chlorophyll and other aspects, which are good, but there's from a lot of the things which are relevant for people's health, like BODs and other things, it's very hard to get any information from those. But slowly, systems are coming in place to leverage different aspects. And the one aspect I want to showcase here is, in addition to analytics, which are now online, you can now start using a lot of these data services to do online analytics. For example, using Google Earth Engine to try and see, let's say, for a particular area, if you wanted to look at elevation data, not just visually, but also in the form of histograms, or if you wanted to have a look at population data, for example, to try and explore from new data from Facebook, for example, which has analyzed high-resolution satellite imagery, and it's become one of the best population data sets in the world at 30-meter resolution. A lot of these are now accessible in the public domain. Again, not just to view, but to do a lot of these kind of analytics, where you can look at how density is different in different parts of the country, the particular basins, and so on. So we wish we could do this for water quality, to make it part of a true multi-sectoral perspective on a basin or a watershed or a coast, where you're looking at not just the hydrology, but also the different users and the different users and the regulators, who all can benefit from improved information of the three I's: the information, institutions, and investments. So looking ahead, this is the last slide, to try and get a sense of, on the investment side, this is the wish list if you were to look at the future. First, to make sure that we have enough investments in the actual in situ water quality monitoring, which will still be required to make the Earth observation data much better. You also need to help not just look at the quality and say it's bad, but to try and improve it through reducing the generation of waste and improving the treatment of waste before they reach water bodies. Because the first environmental engineering textbook in the world, from my old department at Harvard, there's this guy called Gordon Fair, who had big bold letters: the solution to pollution is not dilution. But unfortunately, that's a management measure that's often practiced. And we also have increasingly new nature-based solutions, and also concepts of circular economy, where you're trying to not consider waste as something that have to be produced, but use that within the system itself, so that you have very little waste that goes out of the system like that. On the second eye, on the institutions, The issue is to make sure that water quality becomes a real part of the decision making in integrated water resources management and integrated natural resources watershed management, as well as in that regard to make sure that there's institutional convergence so that it can improve synergy for making sure that there's less water pollution and there's less risk from the water pollution. And this would need to have a lot of people working across these institutions, whether it be government, academia, private sector, civil society organizations, youth, and others. And everyone has a role to play in this at different levels of government as well. And hopefully this can be done with better information. And this is where if we have to say we had a dream, it would include a really open global open access data for in situ data. So just the in situ data itself that's being monitored in patchy ways by different countries, making sure that that is fully accessible. Then a lot of these things that you're doing in AquaWatch, which we've been proud to support as well. So trying to see if a lot of these systems, which are based on Earth observation and in situ and analytics, is also made available through global free open online services. And in addition to that, more web analytics services, because today you go to most countries in the world, nobody has a good model on even their biggest in the developing world, even in their biggest river basin or lake or whatever. There's no limnological model or river basin model which is focusing on water quality, which is accessible to everybody to look at scenario analysis. So we need more of those kinds of things, as well as improved ways of accessing all of these through improved visualization dashboards to help decisions at different levels, and to fill any knowledge gaps with targeted surveys and coordinated research. So hopefully a lot of this is activities that you and AquaWatch can really help with. And we'd be happy to help showcase a lot more of your work, and also to make sure that we can link you up to countries in order to access some of the data sets that might make your products even better and more valuable. So thank you again. Back to you.
Thank you very much, Harsh. I think this was a fantastic, very good overview.
This is Dr. Samuela Guida, Strategic Programs and Engagement Manager at the International Water Association. Today, I'm going to talk about how IWA envisions the needs of science, management, and businesses evolving over the next decade, and how Earth observation can help address those changes. Today, 2.1 billion people lack access to safely managed water services. 4.1 billion are denied dignity of sanitation, and about 1.7 billion people live in areas where groundwater resources and or groundwater dependent ecosystem are under threat. Therefore, the water sector faces a strategic inflection point. More than half of humankind now lives and works in cities. So in cities where we need to figure out how to manage more people with scarcer and less reliable water resources, the International Water Association steps up to nurture, catalyze, and deliver innovative solutions. Over the next decade, the key challenges that the water sector will face are ensuring the basic water and sanitation needs of vulnerable population with increasing urbanization, addressing the impacts of climate change, and tackling a reduced water pollution from point and non-point sources. It is clear that complex problems need integrated solution. IWA takes a system approach and sets the global water agenda by linking research and practice, business and governments, hardware and humanities. To overcome these main challenges, science, management, and business must be practice-oriented, use bottom-up and adaptive approaches, but also use local as well as traditional knowledge. And in this sense, IWA is committed to inclusivity in terms of our membership. And a key initiative for the next 3 years is to accelerate the mainstreaming of the needs, activities, membership, and leadership of low and middle income countries into IWA. So how can Earth observation help address water challenges? First of all, information about water availability is necessary for improved water management and for water security. And in this sense, remote sensing information can fill data gaps and provide inputs for forecasting. Earth observation can also be used as a part of a toolkit to identify if and how water hazard will impact infrastructure and vulnerable population. And for example, satellite imagery can also help monitor pollution and emission, and information can be used to improve the land and water management. And finally, Earth observation information can be used by the water sector to enhance mitigation, preparedness, and the response. And in this case, it is crucial to focus our effort and public spending on areas of greater risk. IWA's work on Earth observation for water management is the result of a successful partnership and collaboration. In particular, we have collaborations with the AquaWatch community and the European project Prime Water. We are part of the Prime Water Consortium, and on the other hand, Prime Water is also part of the IWA Earth observation for water management community of practice steering group. There is also a collaboration between AquaWatch and Prime Water, as Prime Water is represented into the AquaWatch Working Group 1, and Prime Water and AquaWatch collaborate in promoting their activities within their respective networks. And finally, between IWA and AquaWatch, we have an MOU to enable water professionals to access and share information on the application of Earth observation information and technologies for improved water management. And both actually IWA and Prime Water are represented into the AquaWatch steering group. So the engagement on the topic of Earth observation for water management actually supports IWA strategic plans. And this is through professional development program, through leadership development, see the recently launched Earth observation community of practice, agenda setting programmatic work, as the focus on Earth observation is part of the overall IWA digital water program. And finally, global networking opportunities for members. Engagement with AquaWatch, Prime Water, the community of practice really provides an opportunity for our members to network with practitioners that are working on the application of Earth observation in the water management. And so with this, I conclude my presentation. Thank you so much for listening.
Okay, I think we should see the next video now. Is it me not okay, we have some technical problems, will be solved in a minute. While we are trying to solve it, Harsh, if you can, okay. Yeah, okay, you're back. I was just wondering, I had one question to your talk. So the interactive dashboard that you showed at the beginning, this was at the end, this was really looking great. How is the uptake of this? This must be fantastic for some decision takers, particular where such information is very rarely available.
Yes, thanks, Carsten. Yeah, in fact, there seems to be a lot of interest and a lot of hunger, I think, for this kind of information, because I think every institution has been developing a lot of excellent things, but we all have a tendency to throw things over the wall and hope someone catches it on the other side. And I think one of the things that we are trying to do is to at least show a catalog of what's been thrown over the walls that everyone can access. I'm also posting in, I don't know whether I'm posting it in the right place, but in the Q&A thing, the link to this ebook that we just recently made, in which, in fact, Steve also participated in a webinar which we were doing as part of that. And we were surprised that there were about some 600, 700 people who registered for this this virtual knowledge exchange that we organized with our Open Learning Campus. And it was on a much broader set of water indicators that could be explored. But I think there's a lot of people asking about what is the next step on things that especially they can't see easily, like so things such as on groundwater, things to do with the water quality, those kinds of aspects. And this is something which I think we all need to put our heads together to try and see what's possible. I see also in the questions, Anil, who had helped a lot with one of our earlier publications at the bank on Earth observation and water resources, was asking in terms of, how will this actually become a free resource, right? And this is where I think we need to make sure that we can start both for development of all of these, you will need financing for different aspects. But for making it an operational resource, there's many ways now to leverage existing free tools that are out there, whether it be things like Google Earth Engine or some of these evolving Water Data Cube and other aspects and so on. So I think it would be useful to try and see if these can be developed through collaborative approaches like you're doing right now under AquaWatch, and make these accessible as services, which then other people will start putting into their dashboards. Because I think to go away from this, come to my website, look at my 2 pieces of data, to something which is a bit broader, where it becomes a service that other people can access, which really doesn't require much money to sustain, but it does require money to prepare and start these things. And this is where, if a lot more of these can be done, that'll be great.
Yeah, I fully agree. But I said it doesn't need much money, but it needs a little bit, and I think it needs a long-term commitment. I see it really from the Copernicus program. Once there is a big organization behind it, with now the European Commission, and ensuring, okay, this will go for the next 20 or 40 years, then immediately people believe that they can build their own activities on that. And I think at European level, even what Europe pays for Copernicus, it's a lot amount of money, but given overall spending of European Union, is not that much. So I think this kind of institutional funding for this kind of really globally open, available information is needed. And I see that Marc has answered in the Q&A.
And this is where I think you're absolutely right. Things to do, especially with both NASA and the European Space Agency, are the 2, I think, heroes in this space, because they're the ones who made the big funding decisions to put satellites up there, for example, which can be done. The one challenge is in terms of getting the in situ data, having a similar coordination going, that needs a bit more work, I think, because unlike something like WMO, which collects weather data from around the world, water quality, it's still at its infancy. UNEP, others are trying, but it's still at very low levels of coordination in terms of having a standard operating procedure, having shared systems which can be accessed, and so on. And that's something we all probably need to work on, is to make the in situ data better accessible as global free services, which can then be used to also better calibrate, validate a lot of the Earth observation data as well. And then even things which you cannot directly measure from space, you can indirectly measure through models and AI and machine learning and other aspects for using these other data sets.
Yeah, absolutely right. Let me just check with Steve and Mary Beth. Shall we skip the final video and go directly to Q&A? We're already in.
We haven't been able to load it yet. We're still working on it. Yes,
okay,
you want to continue
we
to
go
Q&A.
on talking then.
Please. Thanks.
Okay, right. So then let me see. There are some Q&As. Okay, so the funding we discussed, dashboard inventory, try best practices. I don't know, Mark, do you want to elaborate a bit more on what you said and what European Commission could do in this respect? Mark Dowell, do you want to say something? Maybe you can't, huh?
Yeah, I'm not sure they have audio.
Yeah, maybe I know from when I talked, it took 30 seconds.
If he wants to raise his hand, we can allow him in.
Oh, okay. Do you see? Okay, here's Mark. Very good. Thank you.
Yeah. Can you hear me, Carsten?
Yes, very well.
Yeah, thanks very much for that, Harsh. It was great. I mean, I just had a quick look at the app and the dashboard inventory. I think it's really impressive, and I think what I see as far as kind of reaching a certain categories of users, these kind of dashboard interfaces seem to be becoming more and more kind of the norm. But you know, it's never clear to me if there's kind of best practices, especially when you consolidate as many as you have done in this case, as in defining the user interface for these, because sometimes you happen on some of these portals or dashboards that are just kind of seem to be too complicated. And so do you have any kind of guidance on what seems to work and what doesn't in that regard?
Yeah, really quickly on that, it's a great question, and we've been struggling with it ourselves as well. At the bank, we have a little team that I work with. We call the KIDS, Knowledge, Information, and Data Services Help Desk. And one of the things they do is every day they come up with a new idea in terms of how to visualize some of these data tools. And we've had lots of things that have worked and lots of things that have flopped miserably. So just quickly on some of the good practices as they seem to be evolving. One is to separate the serving of the data services from the consuming of the data services, right? Because often people tend to merge these together into one portal or one thing where you say, okay, you can also access the data here and you can also visualize it here. And that dilutes it. So better to keep the serving a separate thing where people can go in and say, okay, look, these are the things we serve, and to use things which are either open data APIs for more complex data, or if it's spatial data, one of these standard OGC platforms, OGC standards, which are there for serving the data, Open Geospatial Consortium standards. So that way, at least it's an interoperable standards. You can use the same viewing thing and bring in data from different aspects. The other is in terms of the dashboards for viewing. That's where the suggestion is, it's again different strokes for different folks over here, but we suggest to at least start with, especially for a lot of the countries in the world who will not use something that's a subscription service for even basic visualization. If it costs $20 a year, even then, nothing to do with the money, just with the hassle. So it then becomes much more useful to use free services such as Leaflet or something to be able to visualize a lot of these data services that are there, or with a lot of the Python, JavaScript libraries that are out there, amazing visualizations that you can draw upon for free that would be useful to do. You can then use a lot of the public free ones that are there even for the commercial ones, like for example for Tableau or Power BI or other things. They also have free versions which you can start exploring, and in fact some of our kids are doing some amazing work on those, which are great for things like country or within country comparisons and things like that, but not necessarily great for geographical analysis where you need some kind of visualization tool. From people like Esri, you have a lot of these good e-packaging services which are also partly free, things like especially for visualizing or for looking at integrating them into story maps and things like that, which or ebooks. So those become really excellent ways to do these. And you can now do these links to particular types of visualizations, which you can then use in your blogs or tweets or whatever else, because then it changes the way you interact with social media, not just with text saying save the world's water quality, but you can actually start putting in links which people can explore in much more detail and visualize the data that's there. And one exciting thing that we are trying, which we hope to also be showcasing in a upcoming hydroinformatics, blue tech workshop coming up in May, is the use of VR as well. Because now with VR, you can take a lot of these open services that are there and start putting them in VR, which so far has been really nice for meeting people or to try and do games and other things, but really hasn't been used too well on the showcasing the power of data analytics and visualization using VR tools, which are also becoming incredibly cheap nowadays, especially if you use the freer types of VR systems that are there. So there's a lot that's probably changing in the world, which we can all start leveraging going ahead. Hope that answers it.
Yeah, thanks, Harsh, and particular bringing the VR in. But I would like to ask Samuela very quickly, because we will be ready with the next video. But Samuela, listening to the last minutes of discussion, this was pretty much going into this way of bringing the information in a very easy way to users. But I know that the community you are representing is, let's say, much more closer to business activities. And is this the kind of way it's also needed in the future by your community, or do you have a completely different view on that?
Yes, thank you, Carsten, and thank you, Arsh. So, yeah, I think so. I think that so just to give you all an overview, IWA brings together scientists, researchers, technology companies, and water and wastewater utilities. So we have a broad range of.
Fulmer, and I'm the Senior Director for Freshwater Science at Conservation International. I'm actually en route to Senegal right now for my first work-related travel in over 2 years to attend the World Water Forum. So my apologies that I'm not actually able to join you all for this live session or for the Q&A. But I did want to give you a brief overview of the work that we do that intersects with the interests of AquaWatch. So Conservation International works at the intersection of ecosystem conservation and human development, with offices in over 30 countries, concentrated in tropical developing nations. 2 of our pillars of our work are science and partnerships, and so it's great to be able to work with AquaWatch and the GEO community so that we can connect our partners in the field, end users and decision makers, to cutting-edge science and technology. Our water-related work has 4 thematic areas. Inland fisheries, which are poorly documented and understood. And so as a result, they rarely have a seat at the table when decisions are made around food, water, and energy. These decisions often end up harming freshwater ecosystems that underpin fishery health, and fisheries are critically important in a number of the countries where we work. Now, monitoring the water quality of these fisheries, which are often small scale or artisanal, is important, but it's not commonly done. And if we include aquaculture, which is a growing sector in lakes and reservoirs, water quality is an even greater concern, and one in which the GEO AquaWatch community could be helpful. Our next theme is actually a tool, the Freshwater Health Index. Now, this is something I've worked closely on over the past 7 years. Right now, I think it provides the greatest opportunity for collaboration with the AquaWatch community, and so I'll spend most of my time talking about that in a bit. But to round this out, our Wash and Watersheds theme links WASH, which is water access, sanitation, and hygiene, with the conservation sector. These are 2 groups who have traditionally operated in entirely separate spheres, and so we try to bring them together in a watershed approach. And then finally, our green infrastructure theme has been growing in importance, and it's another opportunity for future collaboration. We want to take green infrastructure to scale, so we're not talking green roofs. We're talking forest, wetland, mangrove restoration to generate meaningful and measurable results on water bodies. Our green infrastructure work is both inland and coastal, and one of its main benefits is improvements in water quality. We are starting to invest in plot scale monitoring to better understand what's happening on the landscape, but this can and should be complemented by monitoring adjacent water bodies and their sediment and nutrient concentrations. But with the rest of my time, I want to talk a bit more about the Freshwater Health Index. because this is a long-running program that has already benefited from close collaboration with NASA, and it has the potential to leverage even more remote sensing products. You can think of the index like a state of the basin report, or better yet, like your annual checkup. It's meant to be relatively quick, not cost too much, but it gives a comprehensive overview of health. So the primary outputs of the index are quantitative indicators organized within 3 components: ecosystem vitality, ecosystem services, and governance. And they have 11 indicators and more than 20 sub-indicators among them. Water quality is featured in 2 sub-indicators, one that focuses on total suspended sediment and nutrients, and another that's typically broader. It incorporates user-specified sets of water quality parameters. And although we advise users to apply local monitoring data where it's available, it's obviously not always available, particularly in many of the places where we're working. And so in several cases, we found that remotely sensed datasets have been acceptable and can be used with a hydrologic model to explore scenarios as well. So we have a desktop tool, which you're seeing here, that can be freely downloaded, and that helps with transforming the data into indicators and creating a centralized database. We're also working on web-based tools that will make it even easier for multiple users to collaborate on an assessment. Since the unit of analysis for freshwater health is typically a river or lake basin, river basin organizations and lake basin organizations are an ideal target audience for applying to FHI. But these organizations are usually just coordinators. They're not necessarily decision makers. So it's also important to reach those with real influence over water resource management in a basin. This varies by country and by basin, but it's always going to be a mix of stakeholder groups who should participate and can benefit from these assessments. And so you'll see we work with a range of different organization types, and we get them jointly engaged in co-producing the assessment so they understand the data and they can interpret the results. CI has led the development of the Freshwater Health Index, and through our partnership with NASA, we've made great progress in identifying opportunities to leverage Earth observations data and modeling. We just had an article published in Nature Scientific Reports that illustrates how we've done this in the lower Mekong region. But there's still a need for additional global partners to help us with scaling, as well as finding key national actors like ministries who are willing to adopt this toolkit countrywide. The more data that we're able to provide through existing products, and the easier we can make it for end users to access this data, the more likely that they will engage with the FHI. So as you can see here, in the past 6, almost 7 years now, we've progressed from an ad hoc approach to a much more systematic process, right now guided by our desktop tool. But to really scale, we want to substantially improve our capabilities to access, upload, and transform data. And so that's our what we call phase 3, as we move towards a more centralized web app and get much more into decision support. We feel we've just scratched the surface in terms of incorporating climate change and modeling scenarios for decision support, as an example. We also would like to see a shift from a passive monitoring tool that is creating the baseline assessments to one that's more active and dynamic, can incorporate updated data quickly, and to be a true decision support system. So that's all I've got. I would love to get your thoughts and your feedback. I'm not going to be able to take any questions though, because I'm not actually here. But if you want to reach out to me, you have my email address there. You can also get a lot more information from our website, freshwaterhealthindex.org. Thanks for your attention. I hope the rest of the conference goes well, and hope to hear from you soon.
Okay, very good. I mean, Derek isn't here, but many thanks from this meeting. And yeah, you can put on the board any question, and we will forward it to Derek, and maybe come back to it during the day. And I think this was also, again, quite complementary input also to see the health index idea and as a kind of higher level product, and then how this is integrated in the desktop app and the plans they have for the future. But before we maybe touch upon this, I would like just to come back, Samuela, because unfortunately we interrupted you while you were talking,
No problem.
on the question how your community is putting priorities for future needs based on what we also discussed before. So please continue if you wish.
Thank you, Karsten. Yes, so as I was saying, so at IWA we do not use Earth observation products directly, but we are involved in the promotion of these technologies and the end user engagement. A portal like the one that was presented is definitely useful for our more experienced members who are expert in Earth observation. However, we bring together different members. And some of them are young water professionals. So I think we need to address the needs or also those members. And as I was stressed, as it was stressed in the previous session, I think that we need to address the lack of education and also training at all levels. As per our future needs, I think we need services that address the needs of an inclusive audience, both geographical, gender balanced, age, as I was saying, both senior and young water professionals, but also this language barrier that was mentioned in the previous session. I think we need products and services that are focused on promoting innovation to address what are the global problems and challenges, and we need products that are sustainable and also that are able to address that uncertainty that we will all face in the coming decades.
Okay, thank you so much. Actually, I'm very happy with the session because when I prepared it with colleagues, we were thinking, okay, is it PFTs or more on the bloom? So very technically. Now what we see is maybe the space agencies can just go on and operating what they do right now because the needs are much more on integrating with the population data, as Har showed it, as you said, with the training and education, Samuela. Is this true? Are you for the next decade happy if we just continue delivering TSM and chlorophyll with the current quality that we have and validation, let's say reliability? Can we just go on and you're happy if this is provided?
Well, I leave Arsh as an expert, but I think there is also there is always a possibility for improvement and to bring that inclusivity of the people that we are trying to acknowledge, and those to bring all together. But I leave this to Arsh as a more expert.
No, I think although the name Harsh in my language means happy, let me use the English version and try to be critical of this. I think one of the challenges here is that it would be really useful to see how a lot of this new information fits in the data value chain, right? Because often we start the data value chain from the data side and say, oh, look, here's another cool piece of data that we have. What can we do with this? Instead, we probably should start at the other end of the data value chain at the decisions that need to be supported, whether it be operational decisions or whether it be planning decisions. And to do that kind of decision, what kind of knowledge products would you require? This could be, as we were hearing from the Nature Conservancy, it could be report cards that are there. It could be things to do with different kinds of benchmarking, different trends, other types of insights that you get from the data. And to do that, you'll need a lot of different information, modeling, products, other things that are there. And to do that, you'll need a lot of different kinds of data from different sources. So a lot of these would keep getting made better with time as people go in and try to use different types of tools. And then you say, this isn't very good for this. Can we have a better index for this or better estimate for this and so on, which is by doing sensitivity analysis, by doing other things, you begin to see where you have the knowledge gaps which really need to be filled which are critical for the decision to be made, right? And the decision to be made could be to prioritize areas for cleaning up. It could be to decide where to build the next sewage treatment plant if you only have a few $1 million. What would happen in terms of trying to see the impacts on human health for different things and use that as an input and so on. But all of these will require a lot of work, lots of research, lots of activities to be done. And I think everyone has a role to play in this in terms of adding to the data, the analytics, the insights, the dissemination. As Samuel said, one of the most critical thing is now just improving awareness of what's out there, what could be used, and build capacity. Because now the capacity building is very different from what it used to be in the past. You don't need to make everybody kind of an expert in GIS and remote sensing and modeling and so on, because a lot of these could be automated in a big way. And you could focus more on trying to interpret this and use it for decision support, which is where the critical inputs are really required, which could make it broad-based, and so you can get more inputs from different parts of society and so on. So this is where I think there's still a lot of, unfortunately, work that has to be done in collaboration and coordination, and not in different islands of its own out there. But it will iterate slowly towards these answers, I think.
Okay, thank you. We are 4 minutes before the end of this session, so I would like to wrap up. First of all, many thanks to you both, and also to Derek and the audience. And there is quite some more questions unanswered, so only Q, no A yet in the chat window. I hope that we can come back to it. I'm pretty sure if you look it up, there is Arnold asking for the super-site validation network. I'm sure we come back to this during other sessions today because quality is necessary. And Mona LM was also saying, why are we not satisfied with the quality? So I think we cannot solve it now in this session, but the quality is important, because when we bring it to other people and the quality isn't right, there is no trust in it. So having said this, I think we have 3 minutes to switch to the next session. I would like to thank the speakers and the audience for a very interesting and fruitful discussion. Thank you so much.
Bye. Thanks, Kristen.
Bye. Thank you, Kirsten.